Okay, we have to draw a diagram for this. Now, to draw a diagram for this, you really got to understand what this whole arg notation business is about. Okay, so I'm going to build this step by step, right? Let's just think about arg z. What is arg z, right? Well, it means you have some complex number, z, right? And arg z means, well, okay, what's the angle measured from the origin, right? It's capital A, so it's the principal argument, okay? So that's what arg z is about. Therefore, what are arg z minus 1 and arg z plus 1 about? They're still about measuring an angle, aren't they? But how is it different? So the whole idea is, yeah, there's a shift, right? The way I like to think about it is it's measuring an angle, again, it's still arg, right? But it's measuring it from a different place, okay? So for z plus 1, oops, wrong color. Okay. Z plus 1, I'm gonna measure from here, right? So I'm gonna get this kind of angle here, in here. Is that okay? That angle there, this is my new starting point, and there's my principal argument. So that argument there is arg of z plus 1. Okay? And then for arg z minus 1...
Is it like that? Like, you draw it to z?
Yeah, because it's... Yeah, that's right. It's the argument of z... Oh dear. And I'm shifted. Okay? Really quickly, let's just see if the class is coming in here. What day is it today?
Tuesday.
The class is coming in. Let's talk quickly. Okay, so arg z minus 1 is shifted the other way.
Yeah.
Right, so there's my angle.
Yeah.
Okay, now you do need to remember that when you're doing this, right, this is equivalent to arg of z minus 1 minus arg of z plus 1. Okay, now then your question becomes, what's the quickest way in this diagram to relate these two blue arguments, right? And the answer is, it looks to me like exterior angle of a triangle, okay? In this situation here, this angle is equal to sum of the two opposite interior angles, right? So I'm going to call this theta, right? So arg of z minus 1 equals arg of the two, this is the two opposite interior angles, right? And now you can see this. You see, all I need to do is bring this over, okay? So I'm going to do that in a shifty way. That minus that equals theta, okay? But it's equal to pi on 4. So now I know what this angle in the corner is.
Yeah.
Pi on 4. Now, this is just one example of a z that satisfies this this particular pi on 4, this value that I'm given, right? So I can draw a whole bunch of other ones. It traces out a locus. What locus does it trace?
Oh, pi on a circle.
Yeah, so it forms part of a circle because angles standing on the same chord, right, this arc here, they're going to all stand, they're all going to be in the same segment, okay? So here's what we get.
Also, you can move that point.
Yeah, that's right. So just like if I gave you a circle, right, and you're like,
that's a very perfect circle.
thank you, you got lucky. Okay, so here's A and B, right, and it's like, let me just suppose that this angle here is going to be pi on 4. Right? It's like, well, that means every other angle that's drawn off the same arc, they'll all be pi on 4. They'll all be in the same segment.
So z could be anywhere along those.
That's right. Any of these could be z, and any of these could be z. Okay.